Hi everyone, my name is Andrea. I am a master student at CIbSE, and I'm here today to present the article entitled Toward Supporting the Specification of Context-Aware Software System Test Case. So, nowadays we're seeing the emergence of new types of systems. They have a profound impact on society and users' life. They can interact with the real world, and they share characteristics in common. They are context aware. But what does that mean to be context aware? Well, in this work, context is defined as the overall set of information used to characterize the situation of an entity. And while the context itself is something continuous and abstract, a set of information that cannot be entirely captured, we can represent small pieces of information about the context through context variable. When a software system is capable of capturing this context variable in order to provide relevant information or services to the actors, we say it's a context-aware software system, as known as CAS. But the thing is, the context is something dynamic, it's always varying, and a software system that deals with the context must be ready to adapt its behavior once the changes occur. But it's not what happens nowadays. We can see many software systems that are context aware and they're not capable of adapting its behavior, causing failures and situations such as car crashes and jet airplanes accidents. In this way, cars need to behave adequately in order to avoid this type of failure, and they must be correctly verified. But we are seeing a lack of technologies and strategies to verify whether or not they behave as they should, especially when it comes to the variation of context. In software engineering, software testing is the activity responsible for verifying whether or not a software system behaves as it should, and one of its most important elements is the test case. A test case is composed by inputs, conditions, and expected results. In this way, a set of inputs is submitted to the software system during test execution under very specific constraints, and a set of behavior is expected. If the output of the test process is similar to the expected result, we have a success. If they are different, we have a failure. The thing is, it works for conventional software systems, but when we are talking about CAS, we need to take into consideration the context element and how it would affect the entire test process. In real-life applications, the context variation can occur anytime, and when we are testing this type of system, they need to occur during the test execution in order to be captured, and the behavior of the software system can be verified. Based on that, we proposed CAT-SHARP. CATS stands for Context Aware Test Suite, and the sharp is based on the fact it's an evolution of a previous technique named CATS design. CATS design brings to us the concept of a test hierarchy composed by context variable, threshold, which means the value of the context variable we will assume once the context changes, and the expected result once the variation occurs. We also introduced two new concepts, a new test case model to capture the context and how it would affect the test case, and a new test template to capture the variation of context during the test execution. So, this is the proposed model. We have a fourth element, the context, and each one of its previous elements, input, conditions, and expected results, will be combined with the context elements. Through this model, we can represent four situations. First one, there is no context. We fall back to the conventional test model. Second situation, we have the context influencing just the input. And in this case, conventional test strategies can be used because the only difference will be the increase of the number of test cases, because each different input represents a different context must have different test cases. We have the third situation when the context influences the conditions. In this case, conventional test strategies cannot be used because conventionally, a condition is static during the test execution and they must vary. So we have a new strategies. And last, the fourth situation when the context influences the conditions and the input. We believe in this case we need a specific test environment to support the test of these 4 situations. But there's something we can do in this third situation. I will present now an example application in order to clarify these propositions. So we have a wildlife tracker, which is a wireless sensor network where each node is an animal and each antenna is a base station. Each node has 2 proximity sensors, one for animals and one for base station, battery, solar panel, and the GPS. This application has basically 3 functionality. First one, once the battery is running low, the GPS must be disabled in order to save energy. Functionality number 2, when there is an animal encounter, the data of this encounter must be logged into the node. And functionality number 3, all the information logged into the node must be sent to the base station once the animal gets closer to the base station. Based on this application, I specified 4 test cases, and the test case number 4 represents the situation when there is no context influences, so having a regular input, a regular conditions, and a regular expected result. Test case number 2 and number 3 represents the situation when the context influences just the input. So we have 2 different inputs, one from the base station proximity equal to no, and one to base station proximity equal to yes. And the condition must remain the same during the test execution, and we have to specify the behavior, expected behavior specified. And last, we have the test case number 1, when the animal location will be the input and the battery level should vary and reach the threshold during the test execution. And we have 2 different expected results specified to this case. Now I will present the test template for the test case number 1. So what changes comparing with the regular test template? Well, we added the fixed conditions field, which specify the conditions that must be fixed during the test execution and the condition that must vary in order to test the variation of context. So the battery level must vary, and it must vary on test step number 3. In this way, when the test step number 3 comes, we must pause the system a little bit and simulate it or stimulate this condition to vary the variation of context in order to get this expected result. In this way, we can capture the variation of context and verify whether or not the system is behaving and adapting as it should. So, CATS offer now a new test case model capable of capturing the context and how it will influence the input, the conditions, and the expected result. It also offers a new test template capable of capturing the variation of context when possible. And finally, we must remember that CATS is an ongoing research, and as future steps we have to perform more experimental studies and to build a test environment capable of supporting the variation of context during the test execution in order to turn it easy to do this type of variation and in order to capture the situation when both inputs and conditions will vary. Thanks for your attention. I hope you can meet soon in November 12th when I will present at CIbSE, and thanks again. Bye.